now looks like this. It's flipped over. Now see what's happening on the other end. I've got an asymptote that was here at 3 pi over 2. My parent graph was down here. Where do you think mine will be located with this flipped over and stretch? 6. And then on the end, another asymptote, just like the parent did. And if I connect this, let me extend this. Will the other branch somewhat look like this? It's supposed to be symmetric. I'm not drawn like that. So there's one branch there, one branch there. And guys, there's the graph of this crazy function over here. Now we're going to start checking. See if it makes any sense. Even before the domain and range are listed. Just check and see, is everything in its proper place? Now let me take questions before I start checking.
How'd you know to go to 6?
Beautiful. I'm at 4 already. That's the vertical shift at 4. And it says, please stretch it 2 more. Not shift, 2 more. Okay, not shift, I heard someone say 8. That would be a shift of 4. No, it says just stretch it. Right there. Does that make sense? Up to 2? 2 up, 2 down, so it goes up to 6. What's 6? 6 and what? 2. That's where that came from. David?
Are we gonna go over x-intercepts?
Hang on. Sophia, you got me started. Okay. I may not do it, I'll set you up though. We'll see what happens. Oh, here goes, guys. I've got to watch my time here. Here we go. Aiden, we got to list the domain, the range, period of this graph. But first, I want to know, is the graph correct? Let's check something. Aiden, choose of these 5 points, choose one for me.
3 pi over 4.
3 pi over 4. If my graph is correct, and I go back to the original function and plug in 3 pi over 4, my graph says the answer is 2. If I don't get 2 algebraically, something's wrong. Ramsey's wrong. So I need to take f of, he wants me to use 3 pi over 4. Here goes, guys. Do the best I can here. I know this is tedious. It's tedious for me. Now, I've done so much erasing over there. I think we started out with a 2, was it? 2 cosecant. In the original, what was it in the original? 5 over 4. Subtract what? X? And he says replace x, professor, by 3 pi over 4. Close that up. And then was there a plus 4 on the end? Is that the way the original looked? Okay, here's, I'm hoping. This is 2 cosecant. Guys, inside there, not too bad. There's, at least they have the same denominator. Was that a negative 2 pi over 4?
Yeah.
Let's reduce it down to a negative pi over 2. Plus 4. Whew, hang on. Getting scared. Here's what I would do. Now, there's different ways to do this. Some students will actually find cosecant, which is 1 over y, at negative pi over 2. I would think, wait, now, is cosecant even or odd? Not alternative. Is cosecant even or odd? It's odd, isn't it? We've got 4 odds and 2 evens. Cosecant is odd. What I would do, I would say, if it's odd, just move this negative sign out front, it will not drop. And get out there. Might be easy for me. Now, so this now says negative 2. Now, can anyone tell me what is the cosecant? A, here's your method, which I love. It's 1 over y. What is 1 over y at pi over 2, which has coordinates of those? It's 1. I think. So this says 1 and plus 4. So this is negative 2 plus 4. Algebraically, I got an answer of 2. What did the graph say I'm supposed to get? 2. Now you feel better? Marco, the other four, I got 5 points up there. The other four are supposed to check also, I don't have time to check them. And that's why I asked Aiden at random, just give me one. I checked one, at least one checks. I'm assuming the other four will check. Guys, make sense? So I feel pretty good about this graph. Now, I know what your concern was. Now, let's get the business out of the way. Domain. X cannot be, now here goes, pi over 4, 5 pi over 4, 9 pi over 4, and you gotta come up with a formula. And here's what I would suggest. I would suggest you look at your first asymptote, pi over 4, and ask yourself, how much spacing does it take to get to the next one? How much spacing does it take to get from pi over 4 to the next asymptote, 5 pi over 4? Subtraction 2, what is that, 4 pi over 4, pi? Pi. By the way, just out of curiosity, if you went from this asymptote to this one, 5 pi to 9 pi, is that again 4 pi over 4 distance, or pi?
Yeah.
Is it spacing by pi? So I'm gonna just choose my first one and say, okay, just add to it pi, any number of times you wish, that's k. That's k, is the element of the integers. That k says you may do it any number of times you wish with pi. Just keep adding pi, and you'll get an asymptote. Now, I know some of my students, I would give you full credit for that. I would be so happy. Does anyone see anything that the textbook could do on that answer to change it somewhat? Marco, what do you think here? What could they do?
No,
Yeah.
that's what you.
All right, let's get this out of the way first. How could they rewrite this if they wanted to?
Oh,
Lisa?
maybe so 5 plus,
Now tell me,
maybe like
What should I do?
Put the common denominator as 4.
they could. Here you go, hang on. Pi over 4 plus 4 pi k over 4. Right? I think it's the same as I have up there. And then you're telling me maybe x cannot be equal to, I don't know whether this will help much here, pi plus 4 pi k all over 4,
Yeah, that's what it's.
okay? And I see something maybe a little bit better. I'm just making sure when you check in the textbook or somewhere online, you say, where'd that come from? It's the same thing you actually had, they just simplified it a little bit. What else could I do here, guys, to make that look a little better?
Factor out pi.
Factor out pi, I think it is. David, if I factor out pi on top there, I have 1 plus what, 4k over 4. They may write like that.
Which way do you have to write?
Beautiful, beautiful. If you first do it like that, I'm so happy. I'm very happy. If you write like this. But I simplified somewhat just in case, or whatever source you're looking at for help, they may write a little different and you say, oh, I'm completely lost, I don't know where that came from. They just took your answer and played with it, simplified it. Now, let me use the form here. If I use, Lisa, if I use the form that they may have, if I replace k by 0, right here, that term would drop out. And that would leave me pi over 4. Was that short enough an asymptote of pi over 4?
Yeah.
If I replace k by 1, I get 1 plus 4. That's 5. So I get 5 pi over 4. Was there an asymptote of 5 pi over 4?
Yeah.
So is this giving me the locations of those asymptotes? And I've had some students come up with other formulas. As long as it gives you the locations of those asymptotes. And by the way, this is okay also there. There's my domain. Oh my goodness. Range.
Negative infinity.
Okay, negative infinity up to what number?
2,
2. Thank you. Tell me more.
union, 6 to infinity.
Love it. Stop there. That's my range. No problem. Period. I would take the ending of the cycle, 9 pi over 4 is where it ends with an asymptote, and subtract where it started with an asymptote, pi over 4. And that's 8 pi over 4, that distance. So the period is 2 pi. That's the number that makes things repeat. So I got the period, domain, range. Geez, I can't think of anything else to do on this. guys think of anything else I could ask? I love this problem. I think it's broken down a little bit clearer. Right?
Yeah.
Huh? This helps? Okay, okay. Woo! Now, before I leave chapter 5, take a close look at this. Let's see if I'm ready. Oh boy. Age, we've already checked 1 point. You gave me a point, I checked and it checked. Domain, range, period. What else could I ask? If anything? Oh, I see what it is, David. I see what it is. Sophia. I don't know whether I want to go there.
No, you don't have to.
What are you doing? Are you busy winter session?
Yeah.
Yeah, okay. Now, here you go, lady. Sophia and David and class members, here's the weight professor. That graph crosses the x-axis right here. And it crosses here. There's an x-intercept here. Are they x-intercept? They are x-intercept. These are zeros. Now, for a bonus problem, here goes. Hey, this will be a bonus problem. So let me set you up for the bonus. The bonus will be after you do all this graphing, and you're wiped out, and you look at your time, and it's 7:25, and you know Randy usually stays about 10 minutes more. You got 10 minutes to do the bonus. It'll be like this: 5, 1. Let's just say 1. This thing has many x-intercepts. Find 1 x-intercept. Or let's say 1, 0. Of this function. Then I'll be finished with chapter 5. Done a good job tonight. Your professors done a good job. Are you guys appreciating this? Ooh. You know how much planning takes place here? You think Randy just walks in and does it? No.
Yeah.
I've been planning. Now, on 1, 0, Sophia, I'm hoping they can find this one. I don't know, but we're gonna try. Mr. Parker may have to turn to you for help. Hang on. Guys, if this graph is correct, looks like there's an x-intercept caught between pi over 4, which is 45 degrees, 3 pi over 4, which is 135 degrees. So whatever it is, I don't know what its value is yet. I haven't found it. It's caught between pi over 4 and 3 pi over 4. It might be 2 pi over 4, which is pi over 2. That may be one of the zeros. That might be an x-intercept. I haven't found it yet. How do you find an x-intercept? You go back and set the function equal to 0. Now, oh boy, I've erased this so much. Can anyone, in closing down here, I see a 2 out front, I think it was. 2 cosecant. Now watch carefully. David, help me out here.
Pi over 4 minus x.
Pi over 4 is in fact x. He's concerned about that x-intercept.
And then plus 4.
But plus 4? That's where you find x-intercepts. Sets a function equals 0. You gotta solve that. Now, across the street, they would say, do this to solve it. Move the 4 over. They're not gonna see one like this across the street. Algebraically, they'd say move the 4 over. Then divide by 2. Don't let me make a mistake, because I've done a beautiful job tonight. Now, Marco, cosecant is a strange graph. You see the graph. You might, what a trig function that's a little bit easier to deal with. What other trig function has a relationship with cosecant?
The sine.
Sine. What relationship do they have? They are reciprocals. Look at this. If you're clever, you say, wait, Professor, cosecant, it's a little confusing for me. But change it to sine. They are reciprocals of one another. You could say, oh, I can solve this by doing this. The reciprocal of -2 is -1/2. And now let's change that to sine of that. That might be easier. That's what the relationship is. They are reciprocal.
Oh, okay.
Now, can anyone tell me, I'm on the side here, where on the unit circle have you seen the sign, which is y, equal to a negative 1/2? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. By the way, where is sign negative to begin with? 3 and 4.
3, 4.
So can anyone tell me the size of the angle from the unit circle in quadrant 3, whose y coordinate is negative 1/2? This right here is representing it, whatever it is.
7 pi over 6.
Tell me again.
7
I
pi
thought you had it.
7 pi over 6.
7 pi over 6. If you go to 7 pi over 6 on the unit circle, so all that right there, the green, is representing, David, thank you, this right here, is equal to, representing, in other words, 7 pi over 6. By the way, there's another one in quadrant 4.
So
11 pi over
That would give me another x-intercept. More than likely, it would eventually lead me to this one.
Uh-huh.
I'm gonna find this one.
Ooh.
There's 2 x-intercepts. Let's hope. Here goes. Okay, 7 pi over 6. Guys on the side here, I gotta solve this. Oh boy, Ramsey, be careful. Jeez. I don't wanna mess up here at the end, for sure. Guys, to solve this, start moving things around. Try and solve for x. Can I quickly write this as we're doing blue? Pi over 4, subtract 7 pi over 6 is equal to x. Move things around. I'm looking at it, hoping for the best. Yes, no,
Yeah.
okay? Put those two together with a common denominator of what?
Well, like the least.
That's 12. So I see, 3 subtract, oh my goodness, 3 subtract what? 14?
14.
that's negative 1.
Is that a negative 11?
Yeah, like, yeah.
Negative 11
Over 6.
pi over
12.
6 is an x-intercept.
Yeah.
Do you see a negative 11 pi over 6 on my graph to begin with?
Yeah.
On my graph, you don't see a negative 11 pi over 6.
No,
But
but
it's-
you
it's
can add
the
2 pi.
But
I
it's
got
same
you.
as- it's same as
Guess
pi.
what it is? If I drew another cycle down here, I bet there's an x-intercept down here at negative 11 pi over 6. I don't want that one. I want the one that Sophia wants. She wants the one caught between these two. What I gotta do is to try to find it.
Just add 2 pi.
Negative 11 pi over 6 is down on the other end. I want to know, I don't want that. You want to have an idea to find the one I'm after. That falls between pi over 4 and 3 pi over 4.
Maybe 5 over 4 minus 2 pi.
Method.
Two things. One, shouldn't that be negative 11 pi over 12?
Hang on now, let's see if it is.
It should be 12 because they have.
Well, we got a common denominator of 12 right here.
Yeah.
There's
Yeah.
3 subtract, what was it, 14?
14.
So it should be negative 11.
And then negative 11 pi over 12.
Yeah.
Gotcha, not 6. Thank you, Samantha. Not there. Here. That's what you're telling me here?
Yeah.
Okay, let me step back and look at 3 minus 14, that's a negative 11, I know that for sure. It was a common denominator, 12. Darn it, that's still not the one I want. Mr. Park, I need you. Here we go.
Oh, maybe.
I'm asking Mr. Park something here. Don't confuse us right now. Now, Mr. Park, the guys on the end here was what number, or was there, yeah, plus 4. Jeez. Mr. Park, can you replace x by a negative 11 pi over 12? Let me help you out. That turns out into a positive 11 pi over 12. Oh boy. And we're hoping when you do that, you get 0. At a negative 11 pi over 12. Can you do that for me or not?
So
See
you
if
want
it's sure enough is 0.
me to put in?
That's gonna be a task right there. Is for him to do it with his
Okay.
help there.
Can I ask you? So I plug in x.
Yeah, and x with a negative 11 pi over 12
Oh, okay.
into the original and see if that crunches out. That would save me does it crunch out to be a 0? If it is, it's an x-intercept, but it's not the x-intercept we want. Here, I want to start chapter 6 here. Jeez, look at all this graphic. Crazy.
Wait, I have a question.
Hang on, Samantha, hang on a second. Let me see if these things will check first. Then we'll do it.
Yeah, it works.
Hey, guy, you get a 0?
Yeah.
So that is an x-intercept. Now, Samantha, it's not the x-intercept I want though. There's many x-intercepts on this graph. This thing has many cycles. Samantha, ask you a question.
What do we do with the negative half?
Let me get that.
Negative 1/2?
Oh, she's referring to the green.
Yeah, just to
Right where your hand is.
degree formula.
Negative 1/2 equals sine pi over 4 minus x.
Yeah. So we have like x equals.
Oh, where I got a negative 1/2 down here?
Yeah,
If I change my cosecant, because cosecant's awkward to work with.
but I mean, what did we do with that number?
Yeah, I had to find on the unit circle where was sine negative 1/2. And a student told me it could be 7 pi over 6. Maybe, here goes David. Oh, Lord, here goes. Quadrant 4 says there's another possibility. I think it was what, 11 pi over 6? Guys, here goes. I didn't want to do this, but I think this class needs to see this. I'm gonna set pi over 4, subtract x. Here's another possibility. David, you're saying another possibility is what, 11 pi over 6? Ooh, hang on. There it goes. Do not do that here, guys. Move things around. You got pi over 4. Subtract 11 pi over 6. Oh boy. Equals x. Common denominator of 12. Oh Lord. I see 3. Subtract this time 22. That's not negative. Is it negative? 19? That's not the one I want either, but I bet it's an x-intercept if I had part to check it. I want the one caught between, darn it, this class is gonna be, oh, come on. All the time we spent, I want to find that one.
Maybe,
What else could I use besides, 11 pi over 6 and 7 pi over 6?
maybe rewrite this negative, 5 over 6.
Oh, you mean change this one to a negative pi over 6?
Yeah, what if?
That might do it. Guys, is there another name for 11 pi over 6? I'm thinking myself here. Is it negative pi over 6? Do they stop the same place? Let me see if they do 11 pi over 6. Help me out. That's here.
Yeah.
Is that true? Was the little reference angle of how much? Is that 5 or 6?
Yeah.
And she says, Professor, you could name it as just say negative pi over 6. They stop the same place, so I could rename 11 pi over 6 if that'll help. It was a negative pi over 6. Huh. Lisa, we'll try it. If this doesn't work, let's go to chapter 6. 5 over 4 subtract x. She says, Professor, try negative pi over 6. That's the same as 11 pi over 6. Written a little differently. Now solve for x, move things around. So this is pi over 4. Oh, this might help. Subtract pi over 6 is equal to x. Common denominator.
That's plus.
Plus.
Yes.
Sorry about that. Plus. Now common denominator of 12, I see 3 plus 2. Is that 5? 5 over 12?
Yeah.
My x-intercept first of all between these two. I see a 12 over there. That would be like what, 3 pi over 12? Right? And this would be how much? 6 pi over 12? No. 3 pi over 12 and 9 pi over 12. Does my 5 pi over 12 fall between? This right here is 3 pi over 12. Another name for it. This is, where was it? 9 pi over 12. And the x-intercept I was hoping for falls between those two. And I just found one.
Oh, it does, it does.
Does 5 pi over 12, where on earth am I down here? Does it fall between those two?
Yeah.
That's it.
Yes.
That's the x-intercept.
It's over.
The assumption is what to say. That's good for you, but I don't know for me. Now, would that be a good bonus problem? I'm not gonna ask you on the question itself to find the x-intercept, but since you guys brought it up, that would be a beautiful, beautiful bonus problem.
Oh, we don't have to do it?
Yeah, just find one of the x-intercepts for you. And there's an infinite number of them, just find one for you.
But this is the extra credit.
That it would be an extra credit.
Okay.
That would be an extra credit, maybe a half point. Yeah.
Why did it, well, I mean, I know you said you went the opposite way, but why didn't it work the first time?
It was giving me x-intercepts. I asked him, check those strange numbers that came out. Where was it? Where did we get the x-intercept? I forgot where all this mess was. Oh, right here, I think it was. Right? I didn't check, I think I hadn't checked this, and it was an x-intercept. That wasn't the one I'm after. So then all of a sudden Lisa comes up with this beautiful plan here to rewrite something, and worked out perfectly for me. Finally got the one I wanted. Jeez. Now for the this. If you convert this to degrees, and I ask you guys to do some conversions for me on the ask quiz.
Mhm.
This is 75 degrees.
Mhm.
If you convert to degrees, maybe help with degrees. Back here, we were looking for an x-intercept caught between 45 degrees and 135. Does 75 fall between those two?
Yeah.
That's another way to think of it.
Would you ask us to, write in,
Marco, you get to the point where we are right now. This is extra credit.
above the x-axis or?
No. Oh, where it's above, on the general question, yes. Where is the graph above the x-axis? Where is it below the x-axis? I could do that. No, this would be like an extra credit here. Find one of the x-intercepts for me, or find one of the zeros. for me. Okay, now, I'm gonna run out of time. David, remind the class, and I heard Amy keep on saying, oh, I love chapter 3, Professor. I want chapter 3, polynomial functions, Professor. Let's go back. Let's go back to polynomial functions, right? Now, if you have this, we all know that thing has what? 3 zeros.
Mhm.
And back then, you quickly factored, found them, you smiled, and we smiled, we all smiled. And you got 3 zeros. Were they also 3 x-intercepts on the graph? When you took in behavior, cross touch and all that? Was that true? Same thing's happening here. This is a 0. Strange 0, 5, 5, or 12? Like up here, I guess it's a 0, 1, and -1 are the 3 zeros here, I think. Down here, 5, 5, or 12, and there are many others. Same thing, except they're strange zeros. They got pies in them, maybe. Now, chapter 5, after today, you'll always remember chapter 5. Chapter 5 is done. Now, I think the question to close this down on the test, you have a review for the test. Just say, Professor, how many graphs are you gonna have on there?
1.
If you have 3, I'm done. Professor, out of 80 points, if you have 3 graphs to do, maybe a tan, got that done, and all of a sudden, a secant. Okay, then maybe a cosecant. Can I ask you to do 3? No. Because I have other things to ask you. Besides the graphing. Is that true, David? So I'm gonna squeeze in 2. One's gonna be, it's not too bad, it's sort of basic. One's gonna be,
Like this.
a little bit more exciting. And then on that one that's a little bit more exciting, it's more than likely where the extra credit may come in. Guys, look at it. I think we've done a good job. I think your professor's done a good job. I think all the graphing should make more sense. Now, if you sit down and you say, Professor, I don't remember a thing about this. Do it through transformations. do everything through transformations. And you have it done, okay? Guys, I will not be able to do much, but Mr. Parker brought these in, right? Yeah. We do this for you, just a little glimpse, First, Kyle, I appreciate you. I asked Kyle, in the math 7 textbook, that those of us who move on, the textbook we use here at SMC, I said, Kyle, would you please check out the math 7 textbook and go through, because from what I can remember, they give a diagnostic test to students, and most instructors from math 7 give a diagnostic the very first day. And sort of tell students who may low, maybe not great for math 7. I don't do that for math 2. I did not give you guys a diagnostic test. There's a diagnostic test. So Kyle, he sent me a copy of the diagnostic test in the math 7 textbook. And they're saying you should know day 1 for tree. It's a diagnostic just for tree. Now, I looked at it and I thought, if my students can't pass that, then all this hard work we've done, ooh, I don't know. I'm gonna give you the diagnostic test. Not today, not Wednesday, coming up. It's a short test. I'm gonna give it to you. And maybe a few little extra credit points. Not many, don't get excited, maybe 2. Just to see how you do on a diagnostic, day 1, a math 7 class, and most of those instructors use it. Very first day, they have a copy, and they say, give you so many minutes to do it. They take it up, then based on that, maybe the instructors will, you know, in confidence, talk to you and say, oh, the score was really low, are you sure you're ready for math 7? I don't do that for math 2. I think, oh, some of my students have not had math for a long time. They're not gonna be able to do that well on the diagnostic. Others have just had this and may do a little bit better, but the first day, no, I have to introduce myself and get to start with the syllabus and all that, so I don't do it, but I am gonna give you the diagnostic later on. Kyle, I have it, I have the copy. Now, I'm ready. This is chapter 6, eventually going into chapter 7. Here goes. All that thing I can get done today, I'm over time. I want to look at the sign graph, the basic sign graph, and ask one question to open up chapter 6. Guys, all this is done, if I have a student, or 2, or 3, on Wednesday to get a perfect score, because this test data could be one of those. If I hope I have a lot of students, but if I have 1, 2, 3, with a perfect 80 out of 80, not using the extra credit, 80 out of 80, even plus the extra credit, ooh, would I be happy.
There's no prize.
On this one, would I be happy? Oh my goodness. Now, you said, Professor, what's gonna happen in chapter 6? I thought there's more tree coming up. There is. Now here's the problem. I'm not gonna be able to do much with it, so I'm just gonna right here on the side. Sarah,
Yeah.
I want you to take a good look at on the side here, just what's coming up, and give me an answer for this. Sarah, I'm gonna go back to the most basic graph there is for trig, sine. Here we go. And easy done. He had 0, pi over 2, pi, 3 pi over 2. By the way, as I'm doing this, I'm excited about winter session. Can you imagine those students coming in winter and they're emailing me to add the class? My class is full for winter. 45. 45 before I get to the class, and then I'm getting emails about, Professor, can I get on your ad list? Can I add the class? They want to do all this in 6 weeks. By the time the second week, guess what, David? By the time the winter term, end of second week, I'm doing this. We're doing the graph and trig functions. That's how fast it moves. 6 weeks. You guys have 16. Now, Sarah, back to you. The graph, what does this graph look like? This is a professional problem. I know what the sine wave looks like. It starts here, then it goes up to 1. Eventually it's gonna drop down to a -1, so I'll get ready. Goes up to 1, drops down to 0, -1, sine wave, 0. She says, it's gonna look something like that. Like a roller coaster. Like that. For one cycle, is that true? David, is that true? Yeah, that's one cycle, it's a sine graph. You know what it looks like? And chapter 6 is going to ask you to do this. And so we don't have enough to do. We're now getting our head wrapped around what's going on in chapter 5. There's a no. Now consider this.
Oh, yeah.
Inverse sine of x. Inverse sine of x. Did we not have a quiz that's really about inverses?
Yeah.
Well, and actually find the inverse, and I showed you a way to check it, took a composite, I hope you get an x, and actually find the inverse, right? And you interchange the x and the y?
Mm-hmm.
Okay, Sarah, here's the question. We'll talk a bit, close down. They're asking me to find the inverse on this function. Can you tell the class, Sarah, what's the issue?
It doesn't pass the horizontal.
I love that. It does not pass the horizontal line test. Marco, which says this thing is not 1-to-1. You remember on your test, when I gave you a test for a quiz, I made sure I said this is 1-to-1. If it's not 1-to-1, it has no inverse. So if they want an inverse, they had to, now watch carefully, not me, not Ramsey, I'll call it the committee. Worldwide, they got together. They go, well, how can we make it 1-to-1? For sine, they did this. They go out to -pi/2 on the other side. By the way, guys, is my graph down at -1 at -pi/2?
Yeah.
Okay, like that, okay. And David, they're saying, go ahead and connect this, just like we're going to draw another piece of this. Like that. And here's what they do. Not SMC, not UCLA, not MIT, worldwide. They want this to become 1-to-1, so we can deal with it, so we can find an inverse. They say, please consider only that little piece of it.
That would look like it's.
Now, would that pass the horizontal line test?
Yes.
Yeah.
Now, they did it, not me. So what's it called between -pi/2 and +pi/2 for the domain?
Mm-hmm.
The range is still -1-to-1.
Mm-hmm.
But the domain now is from -pi/2 to +pi/2. You said, Professor, could I not cut out another piece of the graph and made it 1-to-1? You could, but you would not agree with what they did. Those who did this for the math. -pi/2 to +pi/2, now it's 1-to-1, therefore it has an inverse, and the inverse notation will look like this, of course, with a superscript -1, and that's the discussion in chapter 6 when we open it up. Now, when am I going to open it up? Because I'm pressed for time myself. I'm going to open it up Wednesday. Hopefully it'll connect somewhat with what you have on that test a little bit later on Wednesday. I'm going to do just a little bit of inverses with this handout that I'll give you on Wednesday. There. Now, let's just slow down. Take a break. I know you got a nice little Thanksgiving break, I hope.
Run out of paper.
Now, make sure first you check Canvas. I notice sometimes when I put the grades in, I let Canvas do all the work for me. I don't have time to log everything. I put the scores in. And I glance over sometimes, oh my goodness, that student's average is raised up. And I saw that happen with a couple of students when I did this last quiz, May. And then I know some students are stuck at one particular point. They're just stuck. say they're stuck at 45%. I just made that up. And it's not changing. That's all, hold on now, we don't have much more time left. You gotta move on if you expect to move up to the next level. We gotta do something here. So do take note of your canvas and your averages, not Ramsey. Canvas is 1.124 for a grade. Now someone's asking me, so professor, suppose I have an average of 89.9999. Will Canvas give me an A? I check. You got someone had a question? I'll check. So when I finally asked Canvas as an instructor, give me the letter grade, give me the letter grade, they're gonna give me B. I'm hoping that student will, because I have some extra credit on file, will through some extra credit have enough to maybe bump it up with the extra credit points to that little piece that you need to raise it up to that next level. The Canvas 3 program is new. It's not 90%, it's B. It's not 80%, 79.999999 is a C. You guys, check your Canvas. Now, I'm enjoying the class. The class is almost over. This has been one of the best. Mr. Park, I think you would agree. This has been one of the best. He's been with me, what, almost 3 years?
Year.
Are you 2.5 years?
As a TA, a year.
TA, yeah.
Yeah.
How many
1
years?
year.
1 year?
Yeah.
And as a student, that one semester, right?
Yeah. So you're.
Yeah. So he knows, he was seated right where you are right now. He went through this with Ramsey. He walked out of the classroom crying sometimes. Didn't you, Mr. Park?
Mhm.
Did you cry sometimes?
Yeah.
Yeah, that's it. Yeah, I told you. You cry sometimes. No, guys, really, all classes I do with this one. My students are interested. That's the good thing about classes. Some professors will tell me, no, their classes are down to 4 or 5 students.